What it do? Oh, man. Y'all hit me with it, bruh, if y'all can hear me. Y'all know I'll be messing up these little microphone. Sometimes I have it plugged up, sometimes I don't. I'll be forgetting. You would think I'd have it right about now. Episode number 78, 79? Where are we at? Episode number 79, man. Y'all want me that like button, man. We've been doing this for a minute. Log in. What is the login? I think it's root. We're going to use EVE-NG today, man. We only need 2 routers for this lab. I'm going to try to do a couple labs, actually, today. Let me get some light here. Guess that light is on. Woo. Okay. Get my bruh sounds going for y'all. What else we got to do here? Today's lab. Well, we got a couple of them. The first one I want to do is point-to-point protocol. It is a wide area network technology. I have yet to see it in a production environment because, you know, I work mostly in the local area network at my job, and the only time I've really seen this was when, like, during studying for CCNA and stuff like that and Cisco exams. So I can't really let y'all know much about it, but I do know it's a wide area network technology. Do I have? I'm trying to see if I have the topology for it. I guess it don't matter because we're using Eve today, so give me a second here. We got my man Endrit in the building. Lawrence Little, appreciate you for tuning in. Again, just drag and drop 2 routers to your topology. I am going to be pulling up where we at. Study material, Eve. Think I got that saved in HTML console. Here we go. We're gonna give it a couple minutes for some people to tune in as well. Y'all hit me with that like button. Let's see here. Then I'll pull up some news. See what we got working with today. Add a new lab. This lab is just gonna be PPP with CHAP fallback. Pretty much, yeah. PPP with PAP fallback. So I think it's CHAP with PAP fallback. We only need, let's see, hopefully this works. And now, Endrit, since you're tuned into the stream here, you can be a witness to this. If this shit don't work, and I just booted up the EVE-NG VM, so y'all know how I'm a fan of hardware, and this guy been really trying to get me to use EVE-NG because it seems to be the wave. This seems to be the thing these kids are doing nowadays. We're going to go with layer 3, right? He's going to be router 1. I'm going to drag and drop them one at a time, too, this time. Save. All right, there go the plug. Okay, good. At least we're on to something here. Last time I couldn't see this little red plug right here and connect the 2 devices together. Remember when we was trying to set up a, I don't think it was a port channel. I forgot what we were going to do with that lab. Layer 3. Yep, he's going to be router 2. That is the correct image. That's pretty much it. Router 2. Cable them bad boys up together like that. Bloop. Do I want that? Yes. Power them bad boys on. There's a way to start them all at the same time. How do you do that? How do you do that? Where is the button to let them all start up at the same time? It's auto aligning them, I guess. You can refresh to topology. More actions, start all nodes. There we go. Okay. That was pretty self-explanatory, I guess. Again, drag and drop 2 routers like this. This is the lab book we use. We're almost done with it. I'm gonna try to get through challenge lab number 11 through 15. I looked through them. I was like, man, I think we should be able to knock out those first 3. And then in the last 2, I believe one of them is the Ospf lab, and the other one's the Eigrp lab. We should be able to knock those out as well. You can get a copy of this book from 101labs.net, or there's a link in the description box below. It is an affiliate link, so I do get commission if you get it from there. Y'all know how much I love this book, man, because it gives us something to follow along and do hands-on and stuff like that. Because sometimes, if you're just drag and dropping routers like this, right, and you try to, let's say, let's see. Let me try to do Eigrp. And you're like, where do I start? You know, at least this book gives us something to at least follow along as you get better and progress. Then you can start freestyling it, just drag and drop topologies. And be like, I'm gonna put this network in Eigrp, and then put this, you know, segment in Ospf, and you start mixing them up. That's what we're gonna be doing on Fridays, which is Freestyle Fridays. Typically, I stream Monday through Thursday, 8 p.m. Eastern Standard Time. And then if I have time, I will do Fridays where we take all the topics that we learned from Monday through Thursday and then try to, you know, mix those topologies up or technologies up on Friday. Hence the name Freestyle Friday. So let's see here. Give it a couple minutes for some people to tune in and stuff like that. Y'all don't drop off on me just yet. Let's see what we got on the news. Network world, we got a couple of outages. Man, the ISPs had a rough time this week, right? Make sure your laptop backups can handle ransomware. Yeah, no kidding. Tell that to the people that's running the damn pipeline. There's more than one way to back up laptop data, but not all of them can defeat the tricks attackers have designed into ransomware. Yeah, I guess it's yeah, you definitely want to have a backup, and then when you have a backup, make sure you have a backup of the backup. I've been having the same Mac Store 500 gigabyte hard drive since like 2007. I have never really backed it up yet. I really need to, but you know, with ransomware that's just so rampant, man, I would hate for that to lock up my hard drive, man. I've got so much stuff on there. Whew, it just hurts me to even think about losing it. I really need to back it up, man. Back that ass up. All right, so let's go ahead and get started, I guess. Page number, where we at here? Challenge Lab number 11 in the book. Hopefully I got the book. If not, that's fine, because we're going to move on. We're almost done with this book, and we're going to move on to the CCNP version of this book. I'm also going to be doing a giveaway pretty soon on, once I get to about 5,000 subscribers, give away a lot of Boson NetSim stuff, exam stuff. The objective of this lab is for us to configure PAP fallback. This is not covered on the earlier exams or in the CCNA syllabus. So this ain't really, I don't even think this is something in the CCNA exam now that I think about it. Let's see. Let's pull up the exam topics here. I got the exam topics right here for y'all. Let's see. We just do PAP, right? I don't even think that's even in there. I'm gonna close this shit up right here. Control F, PAP. Nope. Can you do PPP? Nope. Can you do chat? Nope. So that's not really on the exam. We probably could skip this, but I'm gonna go ahead and do it anyway. PAP fallback is a useful feature if your chat authentication fails, rather than watch a video solution, blah, blah, blah. So basically, he got two routers just like that, and he dragged and dropped them just like we did right here. The network for this, in case you don't have the book, I'll go ahead and type it in there. How could we type in the text? Oh, right click and then text. That helps. The 10.0.0.x/30 network, right? Save that bad boy right there. So that is that network, right? Can you zoom in? Oh, yeah, you can. Look. Oh, we can't do it that way. Bloop. This device is not large enough. Okay. I guess that's as big as I can get. All right, cool. Let's go ahead and how you console into him? You just double click it. Yeah, I know how I'm used to hardware here, but it's all good. So no, we don't want to do that. We'll start with router 1, I guess. He's booting up, right? He is working on it, right? He is waking up. Okay, good. Obviously, we're gonna make him router 1. Host name is R1. Actually, he's router A, I guess, in the book. It's all good because we're going to knock this out. There's only got 3 tabs. We should be able to knock this out. Configure the topology above. Test by pinging router A to router B. So this interface right here is going to be 10.0.0.1, and that one's going to be .2 right there, right? So this should be a really easy lab. Let's try to knock this out, man. Interface Ethernet 00. His IP address is 10.0.0.1/30 subnet is .252. No, shut that bad boy. What else did they say? We got to do the other side. Go do router 2. Bring him over. Shout out to Indrit in the building over there, man. He was supposed to help me with Even G. Have it in conjunction with Secure CRT. As y'all can see, I'm using these little putty light terminals here. It's all good though. I just didn't have the time to do it because I was working on something else. Y'all got any questions or anything like that? RM said, got Eve to plug up this time. Weird. Yeah, you know what? I got a clue from a man over there, Endra. He said you got to restart. Somebody mentioned that earlier. When you run into that issue that I ran into about 2 days ago, you got to restart the VM. Once you do that, then it should work theoretically. So, and obviously I've rebooted my laptop since then. That restarted the VM, launched it up, and it worked just fine. So, if closing the lab and stopping the devices and all of that does not work for you, just relaunch the VM and that should work. So that was pretty weird. We got Professor Black Ops in the building. Appreciate you for tuning in. Facts, incident response. Yeah, man, let's knock this out, man, because this only got 3 tasks. And matter of fact, CHAP and PAP is not even on the exam anymore. This was an old topic. It's probably in a book. I'm going to check the book, though. That would be weird that they didn't put that in the exam. As you can see, I pulled up the exam topics, and CHAP and PAP, and basically point-to-point protocol is not on the exam. So it is a wide area network technology. I'm pretty sure there's a mention in it somewhere in the book. I will pull it up just to double check, but they don't have it specifically on this exam. However, remember this part right here, this little last sentence right here, right? The following topics are general guidelines for the content likely to be included on the exam. However, other related topics may also appear on any specific delivery of the exam. So in other words, any of this shit free game. They can throw anything they want to at you. It don't have to necessarily be in the exam topic, guys. So, pay attention to that. So maybe that's why Paul Browning put it in the book here. So enable, what am I doing? Global config mode. He is going to be router 2. The book says he's router A, but whatever. Like, we don't knock this shit out, right? R2. Interface, what is that? Ethernet 00. IP address. I did something kind of like for the first time today. Was it the first time? Yeah. No, kind of, I guess in a way, second time in the real world. Having to set up a virtual port channel. I don't know if you guys are familiar with that. With Nexus, it's typically you'll see that on Nexus devices or data center switches. I had to set up a VPC and connect it to an access layer switch. For some reason, the VPC would not come up. I had my port channels to connect and stuff like that, but every time I add it to a virtual port channel, it would go down. So I just left them as individual port channels going to both cores, and then I was able to ping Google, and I'm like, man, this shit worked, man. So I might go, revisit that tomorrow. But that was pretty cool. 10.0.0. What is he? 2? Yes, /37net. .252. No shut that bad boy. We're gonna see if router 1 can ping router 2 like that, right? And then we also gotta do task 2, right? So there's 3 tasks here. So I'm gonna ping 10.0.0. What was he? 2. Pray to the network gods, and we gotta reply. Good to go, right? So theoretically, the other side should be able to ping. So he should be able to ping that side right there, right? That's the other reason why I don't like Putty. I mean, not Putty, but Eve. I can't do my little annotations. Y'all know how I like to draw all these little funky colors and stuff like that, and arrows and stuff, right? That's another reason why I like using the topology and doing that and explaining it. Maybe there's a way to do that on here, right? Let's see. Can you draw on Eve and G? Y'all let me know. Can I do some drawings? I know I can do text, right? I can do a custom shape. I can do that, right? I guess. A square. I got a little square there. Whatever. But y'all know I like my little annotations and stuff with my hardware and the topology. I don't know, man. I'm gonna try to stick with Eve just for now. But so we was able to ping from that side to that side. Task 2 was to configure a CHAP or Challenge Handshake Authentication Protocol with PAP, which stands for Password Authentication Protocol. I can't even remember. Let's look it up. I'm not gonna make pretend like I know. I think it's Password Authentication Protocol. I don't remember. CHAP with PAP. Let's see. CHAP is Challenge Handshake, and then PAP is anybody remember what PAP stands? PAP stands for. Yes, Password Authentication Protocol. With PPP, each system may require its peer to authenticate itself. So basically, we could like create an authentication between the two using the protocol called point-to-point protocol, because we have a point-to-point network here, right? One host in one host, which is why they put it in the /30 subnet, because there's only 2 hosts there. I don't like this little shape thing, man. Delete this shit. Get out of my face with that, man. Delete this shape. Yes. Okay, good. So what do we want to do? Configure a CHAP with PAP fallback. Okay, so they didn't say what kind of password or anything. Ensure that the encapsulation is set to PPP on both routers. We got to go to global config mode, go to the interface, Ethernet, see if I remember how to do this. Encapsulation, no. PPP, no. Oh, don't tell me it don't support it. That might be the reason why. Does anybody know if Eve supports PPP? I might have to Google that as well. And that's another reason why I try to stay away from Eve and G. My hardware, my routers, I'm pretty sure will do this. And if it does, I think that's just probably gonna be the last time I use Eve on my stream here, man. But like I said, CHAP and PAP is not necessarily on the exam topics, but like they said, they may throw a question on it on the exam. So we should at least have some kind of knowledge on it. But however, if you're using Eve and G, I don't think it supports it. I'm gonna look in the solution guide to see if I did that correctly. Yes, you type in PPP and then authentication. Then you pick the authentication type you're going to pick, which we was going to do CHAP, and then the fallback was PAP, which is, it's not as encrypted. I don't think it's encrypted at all. CHAP is encrypted, and PAP is not encrypted, if I'm not mistaken. So, yeah, you go to the interface, you do encapsulation, and you can't even do it. So, it don't even support it. I can't even see. You see why I don't use Eve, man? Y'all want me to start up my router so I will actually configure this for you guys? Or do you want me to just move on to the next topic? Because, like I said, this is a iffy. You may or may not get a question on PAP and CHAP, or in other words, point-to-point protocol on the exam. But y'all know what? Let me do this. I'm going to pull up the official cert guide. Y'all know about this official cert guide, right? Where we at? Let's see if I can pull it up here. Let me see if I can pull it up. What we got here? Y'all hit me with that like button. Also, join the Discord server if I do end up canceling a live stream, which rarely ever happens. Or if there's some new topics or whatever, or if I'm going to change the time. Like sometimes, like I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. But sometimes I may do a Friday, Saturday, or a Sunday. I'll let you know in the Discord server, and that's the invite right there. I'm going to pull up the official cert guide real quick. While that's going, I'm going to actually pull up my routers, because then I would have been able to do it. And we're going to use some serial interfaces for this, right? Yeah, I think we're going to use some serial interfaces for this. Is that what they did in the book? Let's see. Yes, he used serial interfaces. So, let's see. Where we at? Bring that ass back. Bring that ass back. NetworkBruh. CCNA notes. Books. Official cert guide. It could either be in volume 1 or 2. So I'm going to go ahead and open both of the mugs up. Boop. Give me a second here. Give me a second. I'm going to just pull up. Like I said, I'm going to pull up both official cert guides, right? We got that guy right there. This guy right here. It's a wide area network technology. So we go in the book. Where we at? Wide area network technology would be, that's wireless. Let's do this. I'm gonna just control F, PPP. See, it is. They have a mention of it in these books right here. See there? Point-to-point protocol. You see? So they have it in the book. They don't necessarily have it in the exam topics, right? Let's see. What else can we find on PPP? We got some payloads here. There's a mention of it right there. See what I'm saying? Point-to-point serial WAN links use either HDLC, the default, or PPP, the data link protocol. So, like I said, there's mentions of it in the book. That was volume 1. Go to volume 2. PPP. We'll just see. There's nothing, no mention of it in the book in volume 2. So, Y'all let me know if y'all want to cover this or not. We could just move on. But obviously, even G don't support it. I do have Secure CRT, and then we could probably where's Secure CRT? Right there. We could still probably do it on my hardware. Sorry, Indrit, I tried. You see, even G does not do PPP. But then again, like I said, this is I guess a legacy wide area network technology. So, y'all have any questions or anything like that, or any kind of? Y'all let me know, man. Y'all kind of quiet over there, man. Y'all just like PPP shit, man. Listen, if it's not on the exam, then why the hell we covering it? I hear you. So, but just in case there's somebody in here that wants to know a little bit about it, let's see. I got router 1 powered on here. Oh, I just need to set up my plug up my terminal server, and then I'll set it up real quick, and then we gonna knock that one out. Y'all know I like to cover stuff, man. I like to be really thorough. It might not be on the exam, but we don't do stuff just to pass the exam. We want to have some kind of knowledge of it, right? Because we're passionate about this stuff, and we're network engineers, right? That's how we do. We don't just be like, oh, I don't need to know about this because this ain't on the exam, right? We don't do it that way. I'm going to go to global config mode, interface serial 000. His IP address was 10.0.0.1. Subnet mask of 255.255.252. No, shut that bad boy. I'm going to make sure I go to router 2. Where is he at? He's actually router 3. So I actually got router 1 connected to router 3 via a serial cable. So y'all don't pay attention to that right there. It's just router 1 to router 3 because that's how I got him cabled up. All right, so leave me the hell alone. His IP address is 10. Y'all with me so far, all right? 000 or 00.2 subnet mask of /30 255.252. No, shut that bad boy. I'm gonna go to router 1 and see if I can ping router 3, not router 2, router 3. He came up, so theoretically he should be able to. We could also do a show IP route and see if he's in the routing table. We know about the 10 network. Ping 10.002. Pray to the network gods. We got a reply. Let's see if we can set up encapsulation with CHAP. So PPP, point-to-point protocol, is a protocol, wide area network protocol that we use for point-to-point networks. This is a point-to-point network. Why? Because we have one point connected to another point. There's only 2 devices in this network right here, right? It is a /30 subnet, therefore there's only 2 usable hosts in it. So that's why we use /30 for point-to-point networks, because there's only going to be 2 devices in it, right? And then we set the encapsulation for this. Remember the book said? It said by default it's HDLC for Cisco devices. That's probably why too. But we're going to set the encapsulation to be PPP. So encapsulation, does it support it? Do we got to do PPP? What am I? Oh, there it goes right there. I was about to say, shit, my routers ain't got it too. You don't see it there. Encapsulation. Oh no, you got to go to interface. What the hell am I thinking? 000 PPP. No, we got to do encapsulation. There you go. That's what I was looking for. And then this is the default encapsulation for Cisco devices, HDLC. We're going to change it to point-to-point protocol, PPP, right? And then we said, so that's the encapsulation part right there, right? Now, we set the authentication type. We do that with PPP, right? Question mark, and I'll show you. See how it took down the interface too, right? Boom. See how it went from up. It's up on this side, but it's actually down on the other side. Where is it? Come on, man. Okay, so PPP, and then we said it was going to be the authentication parameters, PAP, right? No, we got to do authentication. There it is, authentication, and then we choose the authentication parameter, which was PAP, right? And then the fallback of, CHAP, which is this right here, Challenge Handshake Authentication Protocol. This one's encrypted, stronger. You want to go with that, right? CHAP, and then in case that fails or whatever, it'll fall back to PAP, which is it's less secure, basically. Right click that. We got to do the same thing on the other side. Do we have to set a password? I don't remember. We may not, but we got to do this right here on the same exact config on this router. You notice it went down, right? I'll even show you. Show IP interface brief. We see it was up. It's showing up right there, but the protocol is down. See, right? See that right there? So it's up right there, but it's down. So it's up, down, right? That means layer 1. Layer 1 is up. So the physical cable, physical part, remember cables and stuff like that, and bits and data, that is layer 1, right? And this part right here lets us know layer 2 is not working. So it's up, down, right? Go to global config mode, interface 000, oops, /0. We said encapsulation was PPP. And then we right click this on a keyboard. That is the authentication for the point-to-point protocol. We can verify that with show interface serial 000, I believe, and it should be in there at the top somewhere. There it is, right there. Encapsulation type. LCP is closed. This is like the kind of like the messaging that it uses. And I think that's pretty much it. Let's check the solution guide to see if he did, or actually task 3 actually. What was task 3? Task 3 was check configurations with show commands, which we just did right there. You do show the interface like this right here. Show interface and then the interface number. But it's still showing up down. Did it come up yet? Is it because we got to do the password? Let's see. Let's see. It is showing still up, down. What about the other side? Did it come up on this side yet? No, it did not. So I think we're missing something. What am I missing? Do I have to set an actual password? Let me know. Y'all kind of quiet tonight, man. Y'all really in there just not saying nothing, man? Let me refresh, man, because y'all kind of quiet tonight, man. I usually give shout outs to see some people in there. I only see Professor Black Ops. What was it? We did the encapsulation. Yes, I got to do the username password. That's what it was. Duh. And then have it authenticate. We did the encapsulation, did the authentication. Then you have to actually type in the username password. But either way, whatever. This is what he did. Right? Notice it's down now, right? We are using the same encapsulation type. So either way, let's do this. Let's put in, go to global config mode. He had a username of, what he put? He put the username of the other router, right? Because it authenticates to the other router. So in this case, router 1 is authenticating to router, it's the other way around. You would think, okay, because you're on router 1 right now, right? But router 2, when he is going to authenticate with that, he's going to use a locally stored username and password, which is going to be router 2. So when he logs onto this, he's using router 2. That's why we have to put that username password on there. So it's the opposite. I hope it makes sense that way. Trying to think of another way to, yeah, that's probably the best way to explain it. So this is what he did, right? He put router 2. He put credits for router 2 on router 1, if that makes sense, right? So password, and he put Cisco, right? We're going to do the same thing on the other side. But his is going to be, I put router 2. Let's do this. Let's get rid of that. He's actually router 3. The other guy's router 3. So let me do this. He's router 3, right? Boom. Router 3 is using that to get on there. And then on this guy, username. I can't wait till we move on to the next one. Next lab is going to be challenge lab number 12. We're setting the STP Root Bridge manually. So spanning tree protocol. Username is going to be R1 on this guy, right? Because R1. Password is a lowercase Cisco is what he did. But I think we're missing something there for that. Yep. Username R3, password Cisco. And then that's all he did, though. That is all he did. Then he put log config. And that's it. That's all he did. There, it came up. It came up. So I guess it basically uses the username and password that is stored on there. So we go on the other side. It came up. See that? Remember, see how it was just kind of giving us these messages, trying to authenticate to the other side without the username and password? That's what I got to remember too. Not necessarily because, like I said, I have yet to see it in a production environment. And we got Pete S in the building. What's going on, Pete? Yeah, somebody let me know. Y'all in there, man. I'm like, man, is my chat working? Y'all kind of quiet tonight. So it's all good, though. Show IP interface brief. I think we're done with this lab right here. See, it's up now. It was up, down earlier. Remember? When we couldn't authenticate, it was up, down. Right there. Now we go on this router right here. Show IP interface brief. and we show it is up because they are authenticating using CHAP, and if that fails, it uses PAP, which is not as encrypted. I don't even think it's encrypted at all, if I'm not mistaken. Y'all correct me if I'm wrong, but yeah, let's move on to challenge lab number 2. That calls for 2 switches. Am I gonna use should I use? I should use Eve for this one, man. Let me see, bro. I got a question for you, if you don't mind. Yeah, what's going on, Pete? While you get that question going, I am going to see if I have the topology for the other lab in this book, and then I may use my hardware, because y'all know I just don't want to let go of my hardware, man. We got Anderson Tech Repair 79. Haven't seen you in a minute, man. You've been pretty busy, I guess, but appreciate you for tuning in. There it was, right there. CHAP with PAP fallback. So the other lab is just basically 2 switches back to back. I'm gonna plug up I'm gonna plug up my switches right now. I'm gonna let those bad boys power up. That should be a simple lab 2. I don't feel like messing with Eve today. I ain't got time for Eve today. Not today. Not today, buddy. Let's I guess we can shut everything off. How we do that? More actions, stop all nodes, close. Yeah, we not gonna mess with Eve today. Plus I want my little, y'all know I like my little colorful secure CRT. I haven't had Eve and G to work with secure CRT just yet, so I am going to copy the lab. Real simple lab, just 2 switches, set them back to back to each other, right? Y'all know what the root bridge is for spanning tree protocol, right? It's basically, it's kind of like kind of like the core of the spanning tree network. All traffic needs to go to this core device. It's called the root bridge, or the root. I like to call it a root switch, before it leaves the network, the local area network. So all the traffic must go through the core of the root switch before it leaves the local area network, right? We can manually set who is the root switch on different VLANs, depending on what flavor of spanning tree you got, right? So let's pull up Paint. And this should be a really simple topology. There's only 2 switches there. Typically, when you're experimenting with spanning tree, you gotta have 3 switches set up like in a triangle, right? And that is the classic topology when explaining or experimenting with spanning tree. Again, this book, or this topology, is from the book 101 Labs, Cisco CCNA version 4. It's authored by Paul Browning. Great book. Y'all know how much I promote it like it's my book. What else we got here? It is page number in the book. Hopefully you got the book. If not, that's cool. Page number 513. We only got 4 tasks for this lab. The objective of this lab exercise is for us to configure the root bridge manually. One switch you choose will use the one switch you will use for the priority command, and the other for the macro. So there's 2 ways you can there's 2 ways you can set the root bridge. You can either say, hey, you become the root, and I'll show you the command for that. You don't actually talk to the switch and tell them that. You actually got to type in a command that's just kind of like, it's worded that way. That's called the macro. Or you can set the priority. Remember, the priority is a number from like 0 to like 32,769, something like that. I can't remember the number, but it's in increments of 4096. The lower the priority, the more likely it is to be the root bridge on your network, right? And you can set the priority to like 4096. Whoever has the lowest priority is the root bridge. I'm gonna say it again. Whoever has the lowest priority and something else. It's really the bridge ID, but whoever has the lowest priority becomes the root bridge, right? So, and again, I'm gonna show you 2 ways to do that. What images are you using in Eve? I am using, good question. What is it? The Cisco IOL images, layer 2, layer 3, advanced enterprise, something or other. I don't know. I closed it, but the thing is, you know, just Eve hasn't been nice to me, man. I just like using my hardware. Y'all know what it is. Pete said, I have family who do electrical and data for schools and government. They got a 1921. Okay, cool. ISR 4331 and 2960 and some other devices just sitting here destined for tech recycling or resellers. That's what's up. Those are very excellent devices for a home lab. Jay said, I think your alias is Paul Brown. You would think, man, I'm actually Paul Browning in disguise, man. I'm like this guy in Florida, this black guy in Florida that's make pretend that, yeah, this Paul Browning guy, he's really an awesome author, man. You got to get his book, right? My question is, can I grab those images from the physical devices, then use them in GNS3, or will that not work? Or is it shady? First of all, it is shady, Pete. I'm going to call you Pete. Is that what the S in Pete S means? But, all jokes aside, yes, you can use that image on there and then put it on something else if you want to. Can you use it in GNS3? I don't think so. But correct me if I'm wrong. I don't think you can. I don't know. Let me see. Yes, you can. You should be able to. But GNS3, you will have to have the specific image. Not only do you have to have that specific image, you have to have the appliance. So if you have the 1921 appliance, I don't even know if GNS3 has a 1921, but you have to have the appliance, the exact appliance that will run with that image. So, but yes, I'm not condoning you do that, Mr. Pete S. You should be able to grab them ISO. Yes, that's true. Yeah, but yes, like Jason said, I think you should be able to. They should be able to work. What I typically used to do is, well, I ain't gonna say all that. Just know I think it'll work. I think enough said, right? So let's go ahead and get started, right? We got two switches here, right? Back to back. Let's see if they're powered on right now. Where we at here? Home lab. Switch 1. There he goes. Oh, you know what I gotta do? Yes, I do have them cabled up to each other. FA01 and FA01. And then switch 2. Can I drag and drop it that way? No, I can't. I gotta actually right click it and then go to the tab in the group. And they back to back now connected right now, right? I thought I put him in privileged exec mode. Let's do this. I'm gonna fix that part right there. Interface. What is this? Oh, I guess I didn't put them there. Oh well, whatever. What was I gonna do with him? Line console 0. Privilege level is, well, let me see what he is so far. Real quick, I just need to set this up, man. Line console 0. You show line console 0. I thought show run. Do this real quick, y'all. Show. That's why I needed to fix the privilege level. I wanted to fix that real quick, y'all. Line console 0. Privilege level is 15. Basically, what I'm fixing is, y'all see how when I powered it on, I got this carriage symbol. That is basically in user exec mode. I wanted to power it on and be in privileged exec mode. That way I got to type in enable and then do all of that. The way we do that is 15 is the highest privilege level, so I got to go to console 0 and then set the privilege level to 15. And that's what I did right there, right? Now I got to save it with do right, and that's going to save it. That way, every time I power it on, I'll be in privileged exec mode as opposed to user exec mode, right? All right, so now we got switch 1 on that side, switch 2 on that side. This is the topology we was working with. He said it's all for learning, not like I'm routing packets for the dark web. No, I hear you. I'm just fucking with you. But Cisco has their, these images, that's considered their intellectual property. So you can't be just doing whatever you want. They say, okay, you bought this device, you bought this image, you promised us that you're going to use just that image on this switch or on this router, etc. You can't take it and put it on something else in GNS3 and start lab. We don't care if you're labbing with it. We don't care if you're using, tuning in some guy named NetworkBruh and trying to practice labs and stuff like that. That's not what you told us you was going to do. And every time you power on a switch or you buy a device, they have this, they call the, what's they call the EULA. So it's called the end user end user license agreement. So when you buying all of this software and this hardware, they're saying you're going to use it just for this purpose and not for anything else. That's basically what it is. So I understand you're saying you're not going to do this, but technically you're not supposed to, if that makes any sense. Professor Blackhoff says, stick for the day. The administrator cannot enforce the position. Okay, I like this one. I like this one, Professor Blackhoff. Stick for the day. The administrator cannot enforce the position of the root bridge, but can set the root bridge priority to 0 in an effort to secure the root bridge position. That, I like that fun fact. Cisco wants their bag. You got damn right. So, in other words, yeah, they don't want you just doing anything with their software or their hardware, Pete. So, but yeah, he said, yeah, that's a good tip. That you can't use that. You can't enforce the position of the root bridge, but can set the root bridge to priority 0 in an effort to secure the root bridge position. Okay, cool. So, and like I said, there's 2 ways to do that. And we're going to go ahead and do that. But that's a good fun fact for us, man. For any guys that want to get into cybersecurity. Configure the topology to the above and set the interfaces to trunk. So, he's already switched 1. He's already switched 2. I ain't got to worry about all that. Basically, they want us to set this to be, thickness here, set this to be a trunk, right? We've done that a couple times this week. Y'all know what a trunk is, right? Basically a connection that's going to carry all the VLANs, right? So we got a red VLAN right there. We got the blue VLAN right there. We got the yellow VLAN right there. That's my daughter's new favorite color, right? He can get all of the VLANs that'll come across this trunk right here, as opposed to an access port, which can only use or have one VLAN across it. You could also technically have a voice VLAN on it as well, so really 2. But let's go ahead and do that. I'm gonna go to global config mode, interface FA. Remember I'm on this side right now, right? FA, let's put serial. FA 101. Thought you had to use increments of 4296. Close, Jason. It's increments of 4096, and you can use 0. 0 is the lowest priority. Good question though. 0 is the lowest priority, and then the next number up will be 4096, and then is it 4096? Yeah, 4096, and then I think 2 times that, which is like 8092 or something like that. I don't remember. We'll see. Well, I'll show you real quick. We got to do the trunk ports first. Switch port, trunk, encapsulation, .1Q, right? That with me so far. Now I'm gonna hard code him as a trunk. Switch port mode trunk. Do the same thing on this side. I guess that's what I should be doing. Putting these guys back to back like this. Let me fix his. And notice this one's coming up. This looks a little bit better, right? We should work with this. Work with it this way. The appearance. 216. Okay. Okay. So let's see. Y'all can see this, right? Okay. Yeah, we should work with it this way if we only have 2 devices next time. Episode number 77. Jason said he is a security compliance analyst. Oh, yes, and security checks for Cisco. But, yes, so, yeah, he knows what you're talking about, basically. So, FA00. Oh, y'all can't even see me, can y'all? I took off the damn camera. Why didn't y'all tell me y'all can't see me, man? We're sitting here talking shit. Y'all can't even see me. It's all good, man. Y'all don't even want to see my ugly face anyway. So, what else we did? We set him as a trunk. We got to do the same thing on the other side. We probably don't have to because he's set to dynamic or negotiate, right? So we do show interfaces, trunk. And yes, 101 is set to trunk. Notice I didn't do any. I did. I set this guy right here on that side to become a trunk, but I didn't do anything on this side right here. Why? Because he is on negotiate, and that's what that N means. He negotiated to become a trunk. So he told him, hey, we need to become a trunk. And then they became a trunk together. So I don't have to do that side. Perfect. Task number 2. Configure VLANs 10 and 20 on both switches. Y'all know how to do that, right? So we got to do 2 VLANs on both switches, right? 10 and 20. Let's go through this, right? So VLAN 10, VLAN 20. They didn't say to name them. Show our work with show VLAN brief. There they go. Let's put them both on switch 2. VLAN 10, VLAN 20. Don't worry, Jason, I'm going to get to your priority question. I think that is coming up here. Task 3. We only got 4 tasks for this. On switch A, or switch, I got switch 1 on mine. Right there, he's switch 1, right? Don't get too hung up on that. Switch A is switch 1, switch B is switch 2. Set the priority to ensure that it becomes the root bridge for VLAN 10, right? Let's see who the root bridge is for VLAN 10 right now. It's probably going to be the root bridge for both of them. So, show spanning tree VLAN 10. Who is the root bridge? It says probably going to say this bridge is the root, right? No, he is not. The root bridge is probably, looks like it's going to be the other guy. Yep. So let's do show VLAN 10 right here. Probably because the MAC address. Yep. So I'm going to do show span VLAN 10 on this side. And he is the root bridge for VLAN 10. So he's the root bridge for VLAN 10. VLAN 10. We want to make him the root bridge for VLAN 10. They said to do it, set the priority. So that means we have to set the priority to be, what is the priority for VLAN 10 right now? Priority is right there, 32778. It's actually 32778, which is actually the priority, 32768, plus the VLAN number. So 32768 plus VLAN number 10 plus 10 is 32778. Let's set the priority to make it, he said set the priority to 0. No, he said to just set the priority. He didn't say how. It just got to be lower than this number right here. And now I can show you the increments, Jason. Shit, how we do that again? Spanning tree, VLAN 10, right? 10, question mark, and then priority, right? Now if I question mark, you'll see right there, increments of 4096. You see what I'm saying? Anderson Tech said, for my home lab, I have two 2960 switches. That is nice. Older switch, but it's a pretty capable model. Is layer 3 and layer 2, 24 gig and 48 gig. Good. He got a 2821 ISP router. I got that one as well. That is my terminal server, man. 1700 series router. That is the old school joints. I used to have that. I sold that on, I think, Craigslist. He has a Cisco Pix and 515 firewalls. That's what's up, man. I like that lab, man. I was wondering if anyone could one day assist me in resetting the routers and firewalls to factory settings, please. Yeah, man, we should be able to help you, man. Yeah, like for the switches, all you got to do is hold the mode button. That kind of wipes it clean. Hold the mode button for like 10 seconds. It'll wipe the whole thing clean. It'll say it's receiving a request. That's if you have a password, I believe. But yeah, you should be able to wipe it that way. But there's so many tutorials on YouTube, you'll be able to find it. If not, then yeah, we'll be able to help you out. So that's the priority right there, 4096 but notice right there, 0 through 61440. They said to set the priority. They didn't say which specific number, but we typically, if you want to set this guy as root bridge, you want to set it to be 0. Press enter, and then we'll see. Remember, he was the root bridge for VLAN 10, right? So now let's see. We do show span VLAN 10. It's probably going to be learning and stuff right now. Who is the root bridge? Not yet, not me. It's still this guy, right? We do a check right here. Where is it? Where is it? Where is it? He was the root bridge for VLAN 10. It said this is the root, right? Now it says the cost to get to the root bridge. Now that there's a cost, that tells us somebody else is the root bridge. I wonder who that is, right? Probably this guy right here. So we do a show, and there it is right there. This bridge is the root. Priority is 10. Right? Why is it 10? Because we set the priority to be 0, but the bridge ID is always the priority plus the VLAN number. So 0 plus 10 is what? I know I'm not the greatest mathematician out here, but we know how to do that. It's 10, right? So we set that. Task number 4, final task. Switch B. On switch B, or in my case, switch 2. Right? Switch 2, this guy. Use the iOS macro to ensure that it is the root bridge for VLAN 20. Let's see who the root bridge is for VLAN 20, right? We do show span VLAN 20. Who is the root bridge for it? It looks like he already is the root bridge, the other guy. Probably because he has a lower MAC address. That is probably why. But either way, we're going to set it manually. So right now, it says here, let's see. Let me widen this so y'all can see it better. I should have made these a little bit smaller. It says here, the root ID. This is the information about the root bridge for VLAN 20. Right? That is the MAC address. That is the MAC address of the root bridge for VLAN 20. Let's see. If we do a show version to see what his MAC address is, that's probably going to be this guy, right? Let's see. His MAC address is right there. 081735 F705, right? And it ended at 005. There it is right there. That is it. So, yes, this guy right here is the root bridge also for VLAN 20. And we can verify that with show span VLAN 20, and it says right here, this bridge is the root. So he's already the root bridge, but they want us to use the macro, so we're gonna go over that anyway. The way you do that is you go global config mode, and we say spanning tree VLAN 20, and then what is it? I believe it's just priority root. Priority root? No, primary. I believe it's root. Yeah, root, and then you put primary to make him the root bridge. You could also have a backup root bridge as well and put secondary, I believe, right? Is it secondary? Can't even remember. Yes, secondary. So when you put the keyword primary after the root keyword, this configures this switch as the primary root bridge for this spanning tree. So that is the command right there. Spanning tree, VLAN, and the VLAN number, and then root primary. That is the macro that they were talking about. So it's two ways to set the root bridge for a specific VLAN. You could either set it by priority by typing in number or 4096 or any number as the increment of 4096, or you can use the primary root keyword. What you said? Don't forget to delete VLAN.dat after the mode button. Yes, exactly. Good tip, Biz. 2007, 2008, because that'll wipe your NVRAM. Right? It'll wipe the configurations clean, but you still have a VLAN database, and that's stored in a separate file called the VLAN.dat, just like he just said. Thanks, bro. And I already have the switches set to factory. It's just the routers. Oh, gotcha. Okay. Yeah, there's a different way to do it on the routers. So, due to inheriting them from a friend. Cool. But yeah, there's different ways to do it. It just depends on the models and stuff like that. So, I know I'm leaving you in suspense with this primary keyword here, right? Press enter. Now let's take a look at it. He was already the root bridge anyway. Show span VLAN 20, and he is the root bridge. He's definitely the root bridge, but how did it change his priority? He's the root bridge. It changed the priority to 24596. So that made him the root bridge, and it also lowered his priority, because remember, his priority for that was the default 32788. So what else we got here? Y'all hit me with that like button. Make sure you join the Discord server if you don't have it. Here's an invite in case I make any kind of cancellations or anything like that. This is the lab guide we use right here. Next time y'all want to follow along, we almost done with this book. Like I said, I've said it a million times. We're going to move on to the CCNP version of this. But this is 101 Labs Cisco CCNA version 4. You can get a copy of this from 101labs.net. There's also a link in the description box below. It is an affiliate link. Experts agree that we retain only 10% of what we read, but 90% of what we do. So that's why I'm always preaching you guys, or at least getting you guys to tag along with me, to lab with me and do this. Not just because I need some help from you guys, because you guys usually help me when I fuck up the labs, but it's also to encourage you guys to kind of be hands-on with it. You know, we got Anderson's going to be dusting off his dusty routers over there, and he's going to try to lab with us too. So hopefully you guys are doing the same. We could wrap this up at the hour like we normally do. It is 8:55 Eastern Standard Time, or I wanted to knock out these other labs, man. Yeah, let's do these other labs right here. Enable RSTP was challenge lab number 13. The objective of this lab is for us to configure a switch using the rapid spanning tree protocol. Which version of spanning tree are we running right now? The way we do that is just show. We could just do show spanning tree, right? And it'll tell us on each VLAN. Show span. And we are running right there. IEEE. I think that is the standard. The regular standard. I think they call it classic. Excuse me. Classic spanning tree. Right? They want us to set RSTP, which is rapid spanning tree, RSTP plus. is a different flavor. It is faster, I think it is. It just works a little bit differently. I can't remember all the fun facts for it. God damn it. So we can also do this show run, right? And then what section span? Let's see. Span. Yes, that gives us the spanning tree section. We are running actually PVST. That is the mode we're running. So per VLAN spanning tree. They want us to set it to RSTP. RSTP is used in preference to STP. So let's do this. Go to global config mode. We're going to say spanning tree. Obviously, it's probably going to be just mode, just like that right there, mode. And then we question mark. We'll see for context sensitive help what flavors of spanning tree we can do. We do MST. This is more of a CCNP topic. Multiple spanning tree mode. We can do PVST, which is already running, or rapid PVST, which is what the book called for, right? So spanning tree mode. That's simple enough, right? So see how we can knock this lab out real quick. We change the mode, right? Show span, and notice VLAN 1 is bouncing right now. We're gonna fuck it all up, right? Hopefully we don't blow up these switches here, right? 10-4. Yep. So show span. What else we got going on here? So now notice it said IEEE. So IEEE was really per VLAN spanning tree, right? What was it? It was RSTP. No, RSTP is what we're running now. We was running IEEE. When it says IEEE, that's actually PVST. That was interesting. I thought it was just spanning tree, just STP. I don't know. That's weird, but apparently that was the mode we was running. Now, when we change it to RSTP, it says right there. That's the mode of spanning tree we were running there. So, anybody remember what the differences are between RSTP and PVST? One is rapid spanning tree protocol. The other one is per VLAN spanning tree. The book asked us to do rapid spanning tree protocol. Then it said configure VLANs 10 and 20 on both switches. We've already done that from last lab. On both switches, set RSTP as a protocol. Well, we did it on this switch over here. So we set him to be RSTP plus. We got to do the same thing on that guy over there, right? So easy enough, right? Because we already have the VLANs on there. That's how quick we knocked this lab out. What we said, it was spanning tree mode RSTP. Not RSTP. What he said? Yes, RSTP. And that changes it. Because last time we was running this right here, IEEE, which is actually per VLAN spanning tree. Right? Anybody remember the differences? Let me pull them up. Let me Google them up real quick. Rapid converges faster. Who the fuck, Jason? But can you give a little bit more context, man? I'm fucking with you, but you know, does it converge faster than per VLAN spanning tree? Let's see. RSTP versus not STP but PVST. There we go. I'm pulling it up right now. Right? We got my man Keith Barker in the building. I like that guy, man. I love Keith Barker, man. He's probably one of my favorite CBT Nuggets guys. I'm not that big of a fan of the other guy. What's his name? I can't even remember his name. See? I guess he wasn't that important, but like Network Chuck, obviously. Network Chuck is one of my inspirations. He the one that kind of started me over. You know, I want to be like Network Chuck, but I'll be NetworkBruh. I even grew my beard just like him, too. RSTP stands for Rapid Spanning Tree, while PVST does the same for PVST. It's an improvement of STP, obviously, being new and faster. Difference between, let's see. I wanted a chart, though. RSTP is the 4 states: discarding, learning, forwarding, and listening. I wanted a chart, man. I wanted a chart. RSTP is an improvement on STP. Yes, we know that. PVST is Cisco proprietary. Jeremy C. Jeremy Chara, yes. Yes, I like Jeremy Chara, but there's another guy too. I can't remember the other guy's name is. But anyways, there's the Discord server. In case you guys want to join. That is an invite to it. So like I said, if I cancel, There was a, let's see, there's definitely a chart somewhere between the two methods. Oh, they got this from Packet, what's that called, that website called? They stole that image right there, man. I used to do that too. It is what it is, but you definitely got that from somewhere else. Here's the Spanning Tree Protocol. This is a good comparison chart. Not Packet Pushers, what's the dude's name? Whatever. Let's see. PVST. So the one we was running in this, that's the one that's running. PVST. They wanted us to run this, which they're both pretty much Cisco proprietary per VLAN. 802.1q, ISL. Either way, we'll do this research some other time. I think that was all the lab called for, right? Set both switches as RSTP, configure the VLANs, and set them as a trunk. We already did that from the last lab. That was challenge lab number 13. Challenge lab number 14 is Eigrp, easy Eigrp. So, yeah, and that's exactly what we did. Show spanning tree. Oh, there's another way to check it. Show spanning tree summary. Show spanning tree summary. That lets us, that gives us what, like all of the VLANs and stuff, right? I'll show you. Where is he at? Where you at? Right there. Switches in blah 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 mode, rapid PVST mode. Show spanning tree summary. Tells you which VLAN, how many VLANs, which ones are blocking, listening, forwarding, etc. Yeah, that's it for that lab. Next one is lab number 14, easy Eigrp. We only need 3 routers for that one. So I guess I can turn off those guys. I need 2 serial cables. Do I have 2 serial cables? Let's see. I do have 2 serial cables, but one of these routers need to have 2 interfaces, 2 serial interfaces. Let's see. I'm hoping router 2 has 2 serial interfaces. Yes, I'm running hardware, damn it. Let's see. Does he have 2? Yes, he does. Holla back. All right. So here's how we gonna do this. This is how we gonna do it, y'all. Powering on router 2. I'm gonna reload router 1 and router 3 in just a second here. I just needed a cable up one of these guys. Go ahead and drag and drop while you guys are waiting. Drag and drop 3 routers. I'll pull up the topology in just a second. 3 routers. Right? 3 routers. Cable them up back to back. 1 in the middle. Another reason why I don't want to use EvenG is because I'm not going to be using serial cables on EvenG, even though, like I said, serial is kind of old. So, but for some reason, Paul Browning uses serial cables in his labs. It is what it is. All right. So if you got packet tracer or whatever, I'm gonna go ahead and turn off these switches. Sound like a goddamn no, I'm not gonna do that just yet. Let me delete the VLAN database, like my man Biz said. We got Kevin in the building. He said sounds like an awesome lab there, Anderson. Yep, it is, especially not for switches. Kelvin, you say you can't do that. PS, yeah, especially not for switches. So it's a technical limitation. Switch software is designed specifically to work with ASICs. More specifically, the ASICs on the platform for which they are designed. So there's 0 way to virtualize that. Yes. When Cisco made iOS v2, what they do is take the software of some switch and completely rewrite the underlying hardware abstraction layer to work with a virtual platform. Okay, but with the routers, he could though, right? Couldn't he do it with the routers? That's what I had in mind, was the routers. Delete VLAN flash VLAN.dat. Ah, come on, man. Type that wrong. Same thing on this guy. Is deleting that. Shut these switches off. I got 3 routers powered on. I'm gonna bring up the topology real quick for y'all to see what we working with. Again, router 1, router 2, router 3. Cable them up back to back. Router 3 is awake. Router 1's awake. I'm gonna go ahead and do that right there. Boom, boom, like that. I'm gonna copy and paste the Easy Eigrp lab. Again, we got this from the book 101 Labs Cisco CCNA from my man Paul Browning. You can get a copy of that book from 101labs.net. Another commercial break for y'all. Let's see. New. Bloop. Don't save. Bloop. Widen that bad boy up. Bloop. Let's do this. Let's make this a little bit wider. Just like this. Just like that. Bring that bad boy. All right, and then this is the topology we working with today. 3 routers. Go ahead and cable them up just like that, back to back. Let's go with green for now. No, we got green already in there, so let's go with this little purple right here. No, I don't like that. Let's just go with we'll go with this guy right there. No, I don't like that. Y'all know I like to keep the colors contrasting from each other. All right, so we have, let's see how long, let's see what we working with here. It says 8010, 8020. Let's see what we working with. Let's just start right here. Objective of this lab is for us to configure Eigrp using 2 ASNs, right? I'm guessing this is the ASN right there. It says 8010 and 8020. One ASN will run between routers A and B. So there's router A and there's router B. I guess what we do is change those host names, right? I'm hoping also, let me look at router. Okay, so he's going to be router A, right? Host name, he is our router A. The other guy is going to be, he is router B. Router B. And I'm hoping his interfaces are connected to each other. Show IP interface brief. I haven't touched this router in a while because I was always using router 1 and 2. So yes, I do have 2 interfaces. So that one right there, 010, is actually this. This is 010. Just remember that. Your interfaces might be different. Most likely they are. I said Rapid has discarding, learning, and forwarding states versus disable, blocking, listening. Yeah, I know that the states are different. It's just, man, there's so many damn flavors of spanning tree. But yes, we do need to memorize those states, man. CPU architecture incompatibility. You could with the older routers because they were running on MIP processors that had an emulator called Dynamips, but not with the newer. Yes, that's what I meant. Yeah, and you know I have nothing but archaic hardware, so that's why I told him yes, you can do that. I wasn't really talking about the switches because the switches, like you mentioned, has the A6, which is kind of like it's the chip that's inside the switch that does the processing of frames and stuff. You can't really virtualize that, not really. That stopped being the case around 2006, 2007. Everything has to be designed from the ground up nowadays to work on virtual platforms for those kind of images. Thanks, Kevin. Yep. So that's what I was saying, Pete, is that I was talking, you know, when I'm talking about that stuff, I'm talking about the older devices. So yes, you could have done it with the older routers and stuff. So not necessarily with the switches. And when you said you had some devices, were you talking about the, let's see, what did you say? You said my question is, can I take images from the physical devices? Yeah, you were talking about the routers. Oh, but you mentioned the 2960X. Yeah. That's what it was. That's a switch. So, with the 1921 ISR 4331, I don't remember about those 2 models right there. I don't remember. All right, so router 3 is actually gonna be router C, right? You with me so far, right? I have them listed as router 1, 2, and 3, right here, right? My hardware, but actually it's gonna be A, right, B, and C. We're gonna change that right now, right? Hopefully you're doing the same thing and not just watching, right? So if you got packet tracer, go ahead and drag and drop 3 routers just like that. Cable them up just like this right here, right? Cable between them two, cable between them two. So please don't just watch, man. Be hands-on with it as well. He is going to be host name router C, right? With me so far? So task number 1. Configure the topology above. Test by pinging from router A to router B, then from router B to router C. You will not be able to ping router A to router C until you have configured Eigrp. So this is a really simple Eigrp lab. I guess that's why they call it easy Eigrp. And I guess that's why he could definitely give a okay. So basically what they want us to do is set Eigrp obviously between these two right here, and then connect these two guys right here. And what they saying is he should be able to ping this guy right here, but then when he tries to ping this right here, it should not work. Why? Because he don't know about that yellow network over there. He don't know about this network right here. This network right here. So we got to have Eigrp between these two routers to work right here. So Eigrp right here, and oh, actually this route, yeah, Eigrp between these two, and then he'll learn the routes from this guy right here. So he'll learn about these routes through that interface from this guy right here, if that makes any sense, right? And that's basically how routing protocols work. It's a way to share routes with remote routers, right? From devices that can't reach a specific network. So let's start with router A, this guy right here, and configure those interfaces, right? So I'm going to configure that interface right there, which is 10.0.0.1, right? So we go to that interface serial 000. Oh, come on, man. 000. His IP address is 10.0.0.1/30 subnet .252. No, shut that bad boy. What else we need to do? Let's go to router B and do that interface. Interface serial 000. So this is router B right here, and that is the serial 000 interface right there. Terminal interface serial 000. His IP address is 10.0.0.2/30 subnet. No, shut that bad boy. I hope he comes up. Do I have them cabled up? I believe so. And now let's do this interface and then this interface, right? So we got to stay on router B, right, and do that other interface, which in my case is show. You hear me so far? Show IP interface brief. It's really a real simple lab. If not, just ask some questions in there. I got my moderator Pete and Kelvin in the building. They both smart guys. They can help you out. Configure terminal. We got to do this interface right here. This one right there. I know it says S01, but my interface is different. Remember? So it's serial 010 in my case. So interface that. This. Come on, man. Fucking clipboard, man. I'm sorry, y'all. Get a little frustrated here. His IP address is gonna be 172. Right here, right? 172.16.1.1, and then this guy's gonna be .2, right? You with me so far? 16.1.1 subnet mask of /30. So 255.255.252. No, shut that bad boy. Now we got to go to this interface right here. You can figure that, right? And then we'll do some basic connectivity testing by pinging, right? So we got to go to that interface. Looks like it came up already. Interesting. Probably, let's see what I probably got some old configs on there. He's 10.0.0.2. What the fuck? Router C? Oh, probably from an old lab or something. I don't think I rebooted it. That's what it was. Bruh. I didn't reboot. That was from the last lab, I believe. Or what lab we did. About maybe about an hour ago. Who knows? But we can have a duplicate IP address here. Yeah. We might have a duplicate. But it's up down, so it don't even matter. So we need to change that to be 172.16.1.2. Basically. So interface serial 000 IP address and I meant to reboot it when I went back there to get those cables and stuff. 172.16.1.2 subnet mask of /30 252, right? No, shut that bad boy. And I hope he comes up. Let's see, show IP interface brief. We got looks like we got it up down though. Yes, we got up down. So we need to see what's going on this end right here. So basically we got this side is not working. It is up down, right? Is this side right here working? So we got to go to router B and check that interface, right? So router B, right, looks like it is up down. Show IP interface brief. Where is it? Those both are up down. Interesting. Probably because we did the you know what it was? I think the encapsulation, the PPP and all of that shit that we did from the previous lab. Let's see. Show interface serial 000. Nope. 010. Nope. What was the other one? Who had, I think it was router 3. That's what it is. I believe it's router 3. Watch this. Show run interface serial 000. He has encapsulated that stuff. That's what we got to remove this shit right here. That's what it is. So, and I meant, like I said, I meant to reboot this. You interface serial 000. Right? Y'all with me so far? Basically, that just messed up the lab. I should have rebooted. Let's get rid of this right here. No encapsulation this. Get rid of this right here. No encapsulation that. And where else do I have that at? I believe I have it on router A. Let's see. Let's do a show run interface serial 000. Yes, I do. Let's get rid of that encapsulation, but it's up, right? It is up, I believe. Either way, let's get rid of that. No this. No that. I guess that's why you guys like using virtualization, right? You can just close your lab and then relaunch it, right? You ain't got to worry about wiping configs or rebooting and shit like that, right? Let's see. What does he got going on here? Let's see. I think that's pretty much it. Let's show IP interface brief. He's good to go. So this guy right here is good to go. We need to go to this one right here on router B. So interface serial 000, interface brief. We're gonna check both of them. They should be both up. Yes, they're both up. So this is up and this is also up. Now let's finally see if this one came up. Router 3, it is up. 3, show IP interface brief. There, it's up. Good to go. So let's do some basic connectivity tests here. I'm pretty sure it'll work though. Let me know if you have any questions or anything like that. 1900 and 4300 are all the way past 2006. Yes. I have a 1921 router in here, man. It's all good though. I just don't have the physical space at the moment. Anyway, let's keep labbing for sure. So we're gonna do some basic connectivity here, right? We don't have router A ping router B like this right here. Send him a ping, right? Then what else we need to do? We'll have router B ping router C like this right here. And hopefully them two guys work and we have a happy network here, right? And theoretically, router A, if he tries to ping router C, it will not work. Why? Because he does not know about this network right here. He like, where the fuck is the 172 network? I don't know anything about that because he only sees the routes that are, he only knows about the network that he is directly connected to, unless we add some kind of routing protocol, which in this case would be Eigrp, right? So let's go ahead and do that, right? We'll start off with this one. This guy pinging router B, right? Pretty sure it'll work because we're directly connected and we already checked that they were up, right? So ping 10.0.0.2, right? Because he's .2, right? Pray to the network gods. We got to reply. Good. 5 exclamation points. Good to go. So now let's have router B. Let's go to router B. Bloop. And then have him ping router C right here, right? Should be good to go, right? Ping 172 dot, right here. 172.16.1.2, right? You with me so far? 16.1.2. And we got to reply. Good to go. So now what happens if router A try to ping router C, right? I already gave you the spoiler alert, right? They ain't going to work, right? God damn it. But we don't do it anyway. Ping 172. Watch it work, right? 16.1.2. is hanging there. We got a period, another period, bruh, another period. We got some ladies having a bad month. What's going on here, man? On flow. It's all good though. So, like I said, it doesn't work because they don't know about remote networks. So they only know about the networks that are directly connected to them. We'll even pull up the routing table and I'll show you. Show IP routes, right? That's how you look at the routing table. He knows only about this guy right here only knows about the 10 network as you can see right there, 10.0.00. He is connected to the 10.0 network /30 subnet, right? This L means it's locally configured 10.0.0.1. That is this right here. 10.0.0.1. That is a interface that is locally configured on this router right here. Right? That is what the L means. Right over here. L. And then the C obviously means connected. He's connected to this network right here. So C right there, and the L is right there. The one that is actually, it's right here. Let me get rid of all this shit. But all right. So what else we said we was gonna do? That was task 1. Test by pinging. You would not be able to ping from A to C, which we just did. Task 2, configure EIGRP between all routers with each interface and subnet with the correct ASN. He said ASN, but it says AD10. Is that a typo? I believe that's a typo. He probably meant ASN 10 and ASN 20. Who knows? Y'all let me know. But let's go to global config mode. The way we do that is just router EIGRP. That puts us in EIGRP configuration mode. But you got to put in the ASN number. Question mark, right? You'll see right there. AS. The AS number, I think it's 10. But I don't know. Maybe he did that for some reason. I don't know. Or we can do the instance name. We can do it by name. I've never really done that before. That's the named mode of EIGRP. I'm not too familiar with that. But I'm going to go with, you know what? That's what I like about this book. Here's a solution guide. I'm going to see if he used EIGRP named mode or numbered mode, right? Let's see. It is indeed a typo, and he did numbered mode. So it's EIGRP 10. Not too sure why the hell he put AD 10 there. So that puts us in router configuration mode, and we're going to put the network, this as the network, and the subnet of that. But we don't work with subnets. Can you do subnets in EIGRP? I think you got to do wildcard mask. Whatever. I haven't done that in a minute. So 10.0.0. 0 network /30 subnet, right? Can you do the wildcard bits? Yes. So 0.0.0.3. Remember, wildcard bits is the reverse of a subnet, right? He said, bro, your classes are very helpful. Can you please us on the how to crack the CCNA interview level? I'm guessing you're asking if you get an interview that is like a CCNA level interview, I guess, like a junior network engineer or like a network engineer role. That is something that you would have to practice with, man. So if you have somebody that can do mock interviews with, and they can point out your flaws and things like that, like I might say a lot in my, I don't know if I do it in my streams or not, but yeah, that's just something a great way to do that is, yeah, practicing with somebody that can help you do a mock interview, recording it. That's not something I could give you some pointers and things like that, like I'm doing right now. But yeah, the best way, even now, I already have, I ain't gonna say my dream job, but it is a job that I really wanted, and I was finally able to become a network engineer. But I still go to job interviews just to get some practice. So even if it's a job that you feel like, this job's beneath me, go in there and practice it anyway. Even if it's not a CCNA level, if it's, let's say, I don't know, like a help desk job or something like that, go in there and practice your interviews. That's the best way. Just go out there and do it, man. So I just like teaching the hands-on technical stuff. That's just what I'm passionate about. So this network statement should theoretically put that interface in EIGRP. We got to do the same thing on that for them to become EIGRP neighbors, right? Remember, for them to be in EIGRP neighbors, we got to turn on enable EIGRP on their interfaces, right? So let's go ahead and do that. We did it on this side. Press enter. If we do show IP protocols, we'll see what is running on here. We are running Eigrp 10. We have the K values set. That's by default, right? K1 and 3 are set by 1. The other ones are set by 0, set to 0 rather. This is our router ID 10001. What else can we say about that? Theoretically, his is going to be 10002, right? That is the administrative distance, 90. He is not going to know any routes because he hasn't learned anything from Eigrp yet, right? We'll see. We only know about the 10 network, so he only know about this network right here. So let's go ahead and configure Eigrp on this bad boy right here, right? So we go to router B, and we need to put, remember, when we work with it, we don't do it on just the routers. Like, we don't say, oh, we're going to put Eigrp on this router. We're going to put its interfaces to configure them in Eigrp, or at least have them participate in Eigrp. So in this case, we got router B. We configured it on router A. That interface is participating in Eigrp. On this guy, he is going to be part of 2 ASNs. He's going to be part of that ASN right there and this ASN right there, right? So we need to put this interface, configure it, so that way that interface is participating in Eigrp. And then this interface right here participating in Eigrp. But notice we got 2 networks, right? So, but here's the tricky part. They said 10 and 20 here. So that's the tricky part. Let's see. Let's go to global config mode. We're going to say router put 1 in 10 and then the other in 20. How do we do this? Or do we put 2 network statements in 1? How do we do that? Remember, the Eigrp numbers, they have to match, right? So that is a clue for us right there. Not sure if anyone else uses a best practice to have everything as passive by default and then only have the interface you want as a part of Eigrp. Yes, that's a good way to do that. It makes it more secure. You can do that as well. But I only got like 4 interfaces on this router. It's not like I'm running a corporate network. So, but yes, that is a good way to do it. I think at my last job, that's how they did it. They set everything as default, and anything you want to add, add to Eigrp, you set them as part of that process. So make everything passive. So we're gonna do router Eigrp 10 in this case, so that way we're gonna put this interface in Eigrp 10, right? Because we're gonna have to put this one in Eigrp 20, right? So process number 10. We're going to say network 10.0 security wise. That's a good practice. Yes, exactly, Anthony. So 10.0.0.0 subnet mask of /30. But remember, we don't work with subnet mask. We work with wildcard mask, which is the opposite of a subnet mask of 0.0.3. And in case you don't know how to figure that out, it's basically the subnet mask, right? We know the subnet mask is 255.255.252. We take that last octet and then minus the, or 255 minus that last octet. So in this case, 255 minus 252. That's how I got that 3 right there, right? Press enter. Theoretically, Eigrp should come up between these 2 guys right there. And look, it did it before I even got the finished drawing here. See there? We got Eigrp neighbor. His neighbor is 10001. So basically he said, let me get rid of all this shit right here. So once we put this in the Eigrp in this network, right? He said, oh, look, I got a neighbor. It's 10001. So who is my neighbor? Who's 10001? Oh, it's this guy right there. 10001. That is my Eigrp neighbor. New adjacency, right? So we do a show IP. We run some commands to see what we got, right? Show IP Eigrp neighbor is one way to do it. It says the neighbor is 10001. This is the sequence number. If we have another one that comes up, it'll be neighbor number 2, neighbor number 3. It'll start with 0. So 0 and then 1, 2, 3, etc., right? This is the neighbor's address. The neighbor's address is 10001, right? Where did we learn it from? 00000, that interface, right? Actually, I think that's his interface, 00000. So it's his 00000. The whole time, I think that is when we consider it dead, right? Eigrp has been up for 40 seconds. If I run it again, you'll see it's been up for 1 minute and 16 seconds, right? Remember when this came up? When I said, oh, look, it came up. It's been 1 minute and 16 seconds ago, right? This is the smooth round trip time. Milliseconds is 4. Basically, how long it take for the message to come and come back, right? Or I guess come in and come back. Eigrp messages specifically. RTO is the I think the retransmission timeout. This is the queue count, and this is the sequence number, right? Let's run through this. So let's make these two guys become neighbors, so that way we can go to the next lab, right? I want to do one more lab after this, so I need to go to bed. Shit, router B. So let's go ahead and put these two guys as Eigrp neighbors, right? We are on router B. We're gonna put the other interface in. Remember, in another ASN. The ASN is 20, whereas this one was 10, right? So we do router Eigrp 20, which is not really good practice to put more than one Eigrp process, but it's all good. Like this Eigrp class. What up, bro? Man, appreciate that, Anthony. Y'all make sure y'all tune in, and you guys are labbing along with me. Don't just watch. You ain't gonna really learn it if you're just watching. You gotta learn when you're doing this stuff hands-on. So at least drag 3 routers like this and then follow along from the beginning of the stream. But we typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. And then Fridays, sometimes on Fridays, I'll do Freestyle Fridays, where we take all the topics we learn on Monday, Tuesday, Wednesday, and Thursday, and then we try to mix up all of those technologies up into one topology on Friday. Hence the name Freestyle Friday. So now, again, we're going to do Eigrp between these two guys right here. I know I'm leaving you in suspense, right? And I said I was going to go to bed. We said the network is what? 172.16.1 dot, it says X, so we can just do that 0, the 1.0 network, right? That's the subnet. So 172.16.1.0 subnet. Wildcard mask is the subnet minus the 255 minus the subnet. So let me do it. Let me show y'all. Same thing. It's the same thing. So 000.3 for this one, right? We put that as the network address. What else we need to do with that? That's pretty much it. That's pretty much it. That's going to make this interface participate in Eigrp process number 20. If we do a show IP protocols, we'll see all of our processes. Show IP protocols. Oops. Protocols. And then we'll see. Yes, appreciate what you do for the network community. I've watched almost all your videos. Really good stuff. Man, appreciate that, Bucky. Almost all of them. That's a hell of a video. That's a hell of a video. That's a lot of videos, man. I think I must have done like 150 videos on this channel, man. But that's crazy if you watched all of them, including the live streams. I don't know, man. That's a lot of binge watching of NetworkBruh. Don't know if y'all can take all of that, but it's all good though. Appreciate the kind words there, man. So yeah, we're running process Eigrp 10, which is this right here, and also Eigrp 20, which is that process right there. Right? What can we say about these two processes? That is the ASN, or the AS, autonomous system, right? Autonomous system is basically a group of routers, or at least a group of routers that have interfaces in a specific process, right? So this interface and that interface, that's why I don't say routers. We don't say, oh, this router isn't participating in Eigrp. We're saying the interfaces, because like this router right here, yes, he's participating in Eigrp, but he has that interface participating in process 10, right? And this interface participating in Eigrp 20. That's why we don't say routers. We say the interfaces are participating in specific processes, right? Or ASNs in this case. His router ID is 172.16.1.1. Here's the tricky thing about this, though. That changed his Eigrp router ID, didn't it? Did it bounce on the other side? Let's see. It did bounce. It did bounce. Because, let's see. It did bounce. Because we changed the router ID by putting another process on there. So now, remember when we did show Eigrp, did we do show neighbors on this? When did we didn't. Let's see what his neighbor is. Eigrp neighbor. Oh, he's still 10.0.0.2. So yeah, okay, that's why. So that's still 10.0.0.2. That's the router ID. But on this side, his router ID is going to be 172.16.1.1. Right? That make any sense? Okay, let's go ahead and do this right here, and they should all become neighbors. And then theoretically, this guy, once he learns some routes, should be able to finally ping router C like that, right? So router B, I'm sorry, router C, let's go to router C, right? I'm gonna go to this guy right here and configure that interface right there. Router C is right here. We'll go to global config mode, interface serial. Ooh, did I fuck that up? Let me see. No, I didn't. No, I didn't. Okay, good. Let's see. He should have. No, he don't have. He only got one neighbor. So show IP EIGRP neighbors. Yeah, he only got one neighbors. But he will typically have, this guy right here should have two neighbors, right? That right there, and this guy right here. So he should have two neighbors, and these guys have one neighbor. Does that make any sense? Right? He only sees one guy. He only sees one guy. But remember, he in the middle. So let me not say any sexual innuendo or anything like that. But y'all don't know the hell I mean, right? So let's go to router C and go to interface 00000 network. I mean router. No, we didn't do it that way. I'm doing it the other way. That's another way to do it. Exit. Router EIGRP 20, right? And we're saying network. We're gonna have this interface right here participate in EIGRP 20. How do we do that? 172.16.1.0 subnet mask of 0003, and that should bring up a neighbor. There it is right there. We go to router 2 or B. We're gonna go with him, and we'll see those two neighbors that I was mentioning. Right? Notice we got a message right here, new adjacency. Right now we do a show IP EIGRP neighbor, and now he got two neighbors. Right? 10.0.0.1. Who is that? This guy. And also 172.16.1.2, which is this guy, right? That make any sense? So now let's look at the routing tables. I'm going to look at this guy's routing table. This guy. Remember, he only knew about the 10 network, right? So now that he learned some routes from this guy right here via that interface, he should theoretically know about this network now. He should be able to know about that network right there now, right? We do a show IP routes. Router B is a player. Man, listen, man. Exactly. Router B is just like, hey, man, he playing the field right now. Show IP routes. So not only does he know about the 10 network, this right here, he also know about the 172.16 network, this right here. So now if we try to ping 172.16.1.2, yeah, go to router 1. Or router A rather. Look at his routing table, show IP routes. Oh, see, no, he doesn't. What are we missing here? We're missing something. He doesn't know. He doesn't know. I was looking at router A. Oh, who was I looking at? I was looking at router B. He know about the two networks, but he hasn't. This guy hasn't learned. The other guy hasn't learned anything through EIGRP yet. See there? So we're missing something. I am missing something. I would not be able to ping router C, but we'll try it anyway, and I doubt it because look, it's not even on the routing table. I'm not going to do that and embarrass myself. What am I missing, y'all? Go to router B. Let's see. Didn't he has two EIGRP neighbors? He's got two EIGRP neighbors. So, but I think he should be able to ping it though because the other guy has neighbors. No, because he should have. It should show up on his routing table too. Oh, what's it gonna say? See, watch 172.16.1.2. See, he's gonna hang. So he can't ping this yet. I think I'm missing a network statement. Redistribute. I don't think they introduced redistribution command on this. Nah. Especially the fact that they called it easy EIGRP. Redistribution is not a CCNA topic. It's more of a CCNP topic. So no, they wouldn't have done that. I want to go in the book, but I don't want to do that. Y'all know I like to try to refrain from using the solution guide. What am I missing? We put them in two different routing protocols for one. Or not routing protocols. Two ASNs. We got ASN 10, that right there. This one is ASN 20, that right there. But we need these to learn about those networks and vice versa. Right? Show IP. There's something that's gonna click once I see it. I don't remember what. Protocols. What am I missing? Protocols. That is running for the 10 network. Automatic summarization disabled. Do I gotta do no auto summary? That's probably it. Because it's doing the 1030, 10.0/30 I don't think that's the problem. You said I'm missing the network. Like the network command, show run section router. I got the network commands. We have that router participating in 2 Eigrp processes. Do I gotta do no auto summary? I'm gonna do that anyway. Go to global config mode, router, Eigrp 10, no auto summary. Let's do the same thing on 20. It's gonna bounce, right? No auto summary. No, it's not. Routes. Y'all see what I'm missing? I'm missing something. And they called it easy Eigrp. But yet the network, bro, can't do it. Let's see. Show, what are we missing? So what are we missing here? What are we missing? Let's do no auto summary on all 3 routers. Let's do that. Router Eigrp 10, no auto. Let's do it on that guy. I don't think that's the problem though, but I'm gonna do it anyway. Router Eigrp 20, no auto. Oops. Auto summary. Does he have a neighbor? Show IP Eigrp neighbor. He has a neighbor. Did you configure the interface for 172? On what router? On router B? Let's see. I'm sure I did because it wouldn't have came up. Show IP interface brief. There's the interfaces. 172.16.1.1. The other one should be 1.2, right? Show IP interface brief. He's 1.2. Show Eigrp. He's not learning any Eigrp routes. Router A should get some. He should learn about the 172 network. Show IP Eigrp neighbors. He has that as a neighbor. Show IP routes. Yeah, see? Interesting. Serial 00. Oh, 0. Oh, let me see. 010. That right there. That is participating. That interface right there is participating in Eigrp 20. Right? Right over here. Anything in the 1.0 network, put it in the Eigrp 20. So let's see what I'm missing. I'm pretty sure it's just like one simple thing that I'm missing. Let's see. Yes, you're right. The redistribution command. That's what it is. Who said that? Bucky Rouse. Shout out to Bucky. I didn't think they would put Eigrp on there. I mean, redistribute on there like that. Interesting. Look, he even said that too. This is why I like Paul Browning. He said on the solution guide, this is why I like the solution guide too. I cheated a bit here, so you may have struggled. Yes, I did, Paul Browning. ASN 10 will not speak to ASN 20 without you adding another command not covered in the CCNA exam. So shout out to Bucky for that one. He got that correct. We are missing the redistribute command. And I was thinking, nah, he wouldn't have put that in there. He even said it too. I cheated a bit here. But I do know that Cisco can be sneaky, and I've seen other stuff not in the syllabus put into the exam, leaving the test taker confused and angry. I can't say I blamed them. Paul Brown, if you are watching this, man, you are a sneaky little bastard, man. But just stuff like this. This is why I like this book, man. But you see, and I was thinking, there's no way he would have put that command on there. That's not a CCNA topic. But yes, that is what it is. The reason why is this network is not going to be learned by this network until we redistribute it, like what Bucky said. So shout out to you, Bucky, for getting that one correctly. And I was thinking, really? Nah, they wouldn't have done that. So just have a play with the redistribute command and then redo the lab, but just put everything into ASN 10 and it will work fine. So, and I thought about that too. I was like, why did he put two separate networks? I mean, two separate ASNs there. That's the problem. So we got to basically, we got to put this network, we'll put it in in Eigrp 10. So let's do that. We're going to get rid of Eigrp 20, right? Little bastard, you. I would think would see AD 20 as external Eigrp, vice versa. I'm trying to think. I think you would still have to do redistribute and then change the metrics and do all that shit to do that, for that to work. I can't remember. I haven't touched that stuff in a minute, and this is why I'm going back to the fundamentals and stuff. So go to global config mode and let's do that. Let's get rid of. So there's two ways to do this, right? I think that's what he said here. Let's see how he did it. Go to 10. Oh, go to 10, redistribute 20, and then go to 20 and redistribute 10. Or you can just put everything in one ASN. So let's do the redistribute command, like what Bucky said. So we're gonna go to, let me see, where we got to do it on. We got to do it on router B. So all the redistribution has to be done by this right here, right? He's gonna be redistributing those routes, right, to that way and that way. So that way they can learn about each other. So we'll start with 10. So we go to router Eigrp 10. We're gonna say redistribute, and then is it Eigrp 20, right? We're gonna just redistribute 20. So we're gonna redistribute this into that ASN, and then vice versa, right? So we do that, and then we go to router Eigrp 20 and redistribute Eigrp 10. And now we do a show IP route on this guy. Does he have those routes now? Yes, he does. And that's what you were mentioning, the exclude the external route. And that's what we were missing right there. So when you redistribute, since it's a 170 AD. Yes, exactly. Just like what you said. The AD right there is 170. So he kind of fucked it all up for us by steering us one way, but didn't just left something out here. So that's, he even said I cheated a bit here. So that's why y'all fucked it all up for us. So and it did look kind of weird to me, but I was like, oh, I'm just gonna follow it. Y'all know I like following this book to a T, but that's the reason why it didn't work. So now he know about the 172.16.1.0 network, and just like Bucky said, it should be an external route learned by D, which stands for what? Eigrp, right? So D for Eigrp, it is an external Eigrp route. That's what the D and the X means, and the EX means. That's the network, 172.16.1.0 network, right? This right here, right? Right, that guy right there. That's the 172.16.1.0 network. 170 is the administrative distance, and that's the metric. We can learn that. We can get there through 10.0.0.2. 10.0.0.2, which is what? This network right there, right? So now, theoretically, this guy should be able to ping across that guy right there. So, ping 172.16.1.2, pray to the network gods, and we got a reply. Next time you guys want to follow along, get you a copy of this book, man. Hey, mistakes is how we learn. Yes, he steered me wrong, but he did that on purpose. And I was just like, there is no way he would introduce the redistribute concept. And you did mention that about 10 minutes ago. Y'all even go in the chat room and you'll see he even said redistribute. I was like, nah, yeah, but he wouldn't have done that to us, man. Yes, he would, apparently. Y'all want to do one more lab? One more lab? I should look in there and see if he cheated on us again. I don't think he did. Next one is just Ospf passive interfaces. I'm going to practice that one. I'm going to definitely practice that one. Hopefully, I have time to do a Freestyle Friday so that way I can practice more redistribution. But yes, that's what we needed to do, man. Challenge lab number 15, page 520, is OSPF passive interfaces. So, who was it that mentioned passive interfaces? I need that book. Yeah, man, it's all good, bro. Get you a copy of this. There's a link in the description box below. It is an affiliate link, or you can get it from their website, 101labs.net. And like I said, this gives us a lot of practice, hands-on and stuff like that. It's just, you know, when you've gone through it, it's better to practice it again. So we get the concepts ingrained in our mind and stuff like that. Now we know when there's two different processes, we need to redistribute them, even though it's the same routing protocol. I used to think redistribution was just for, you know, one routing protocol to another routing protocol, like OSPF to Eigrp. But no, you can do Eigrp into Eigrp if they're different processes. So that was a tricky one right there. You got any questions or anything? Y'all want to do one more lab, or y'all calling tonight? Y'all let me know, man. Y'all know I'll do this shit all night if y'all want to. I like learning this stuff, man. Next lab only calls for 2 routers. Let's see, what does he do here? The objective of this lab is for us to configure single area OSPF, and it doesn't look like he does any tricky things. I hope he don't do that in the CCNP book, man, because damn, that shit, man, that would be pissing me off, man. Like, man, this dude keep fucking it all up, man. It's like typos. Ping across the serial interface because there's no routes. Configure single OSPF. Set the loopbacks to be a passive interface. Y'all let me know if y'all want to do one more lab, man. If y'all want to call it a night, I'll copy the topology. OSPF passive interfaces. Yeah, I want to do one more lab, man. That way we can knock this out. That will be all of the challenge labs, man. That will be all of them. Then after that, we have, what else we got? We got some bonus labs in this book. A through, what is that? Looks like it's like A through F. A through G are the bonus labs. A through G. Nah, let's just hold off on that, man. We'll do this tomorrow, man. We'll do this tomorrow. I thought I was gonna keep going, man, but man, let's just cut it short, man. Yeah, so yeah, get you a copy of this book, 101labs.net, or there's a link in the description box below. Let me give you a link to the Discord server. This is an invite for you guys in case I cancel a stream, which I rarely ever do lately. And also, if we end up doing a Freestyle Fridays, because typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. If there is a bonus live on the weekends or on Friday or whatever, I will let you know in the Discord server. So make sure y'all join that. For now, comment, like, subscribe to the network.